Welcome everyone. This is video number 2 in a series based on my book, Learn Harmony V3 for PIC32MZ. Video 1 showed how to set up a development environment for programming PIC32MZ devices. In this video, we will create a base project using the Curiosity 2.0 PIC MZEF development board available from Microchip. This base project will be used in future videos. By the way, if you like this video and want to see more, hit the subscribe button on the screen. So let's get started. First, we have to create a directory under the Microchip Harmony V3 directory named apps. Then create a subdirectory named MZEF base, which is where we'll put our base project. You'll see that here in the tree, directory tree, Microchip Harmony V3. This is the one you're creating, apps, and then the subdirectory MZEF base, which is the name of our project. So the reason we do this is that all the apps we create will be under apps, under V3, and then this is where all the software components from Harmony reside. So as we add more, they'll show up here. We add more apps, they'll show up here. So it's all in one place where you can find it. Okay, so now we just have to make sure your development board is plugged in to the USB slot. Open MPLAB X. Okay, we're going to start a new project from scratch. So go up to the top level menu in MPLAB X, File, New Project, and notice Microchip Embedded 32-bit Harmony 3 project. If you don't see the Harmony 3 project, it means you haven't loaded the MHC, so go back to the previous video and make sure you load the Harmony stuff. Okay, so now we're going to launch the Content Manager, which if you just created everything, you don't really need to do, but if it's been a few days or even a week, you might want to check to see that there weren't some updates to the software components, which come very frequently, and you have to be aware of that when you're doing a project that takes a long time, that there will be changes in the Harmony components while you're working on it. So you need to understand that. So we'll do that. Framework path is the way where we loaded all the Harmony components. So click Next. And it said the test was successful. It's hiding here in the back. And okay, we're going to look at the local packages. And that's what we loaded originally: Core, CSP, DevPacks, MHC, and QuickDocs. And look at that. We've got, just in the time week or two, we've got updates. So let's download those. So we have the latest versions of everything. We've got enough problems without mixing versions. So these usually go pretty quickly, as they have. So now all of our local packages are synchronized and ready to go. So we'll close that out and just back up. The framework path is the correct one, so we'll click Next. Okay, the location is where we loaded all those packages. I prefer to put everything in the same area in my hard drive rather than have it spread all over. So let's go back to the high level, microchip, Harmony, V3, and apps, and MZ base. Those are the two directories that we just created. So we'll click on base, which is the name of the project we're going to be working with. And so there's its location, just where we created the directory. Okay, the folder, we're going to give it the same name as the project, and it fills that in. All this is correct now. Okay, now this name is used by Harmony to create some subdirectories, so don't use the same name as your project. For this case, I'm going to use it, make it the same name as the chip. Device family is PIC32MZ. Now the name can be anything you want. You just have to recognize it. Target device is what we're using on that dev board. EFM PIC32MZ 2048 EFM 144, 144 pin. Okay, so that's got that all set up. We're finishing that, and it's going to now create some directories in our designated area, and it's going to launch Harmony configurator, and these are the latest device packs, so we're going to launch that. Notice there's the notice of the update that we just downloaded. So it's cranking through whatever it has to do. There we go. So we've loaded two components in our project graph here. We go over here to the Projects tab and the dashboard down here, and it'll show you this is like the Harmony version 2 look, which I like. So it's established an architecture underneath the project name, header files, important files. So just look and see, there's nothing there. It's just setting up the directories. So we click on each of these. You can go over here to configuration options. In this case, there's really no configuration option. It's just telling you information about the device family pack that's loaded, which is 1358, also down here. So now we'll go to the system, and the configuration options are quite extensive, and in fact, they don't fit very well on the screen. So what I'm going to do is right-click here on the title and float the windows so we can see all these options a little better. So we'll just start at the top and start configuring these things. I've got a bunch of configuration like registers, and so we'll go to each one of those, and most of the defaults apply here, but there's a few that need adjustment. So this one, not exactly sure why, but later on, if we do the TCP/IP library, this setting seemed to be important. So the rest of them are okay. Configuration 2, we want to change the PL range to 8 to 16. And this one here should be 12 megahertz because that's on this particular board, that's what they chose to put in there. So I have to make that adjustment. Configuration register 1 here. We go down here to POSC mod and choose EC. If you want to dig deeper, go to the data sheets and find out what these things mean. But at this point, we're just trying to get something to work. And without some of these changes, your project won't work. So down here, gain level 3, change those to gain level 2. Not exactly sure. And this one should be off. At this point, we just do it. Again, go to the data sheets if you want to find out exactly what that does. But this is it. Project configuration. Generate main source files. This is, yes, it's going to create a file name called main. Generate all the source files, yes. Toolchain selections. Compiler XC32, yes. And XC32 global options, linker, general heap size. We're going to change the heap here to 64,960, which is a number that came in to some of the TCP/IP stuff. So let's set it now so we don't have to think about it. And let's see, that should be about it. MIPS configuration, cache, use cache maintenance, not sure, just did it. Prefetch. I don't know, I'll change that to 2. These are all okay, except at the end here. Configuration settings. Let's just look at each of these. These are all 2s, except that one. Clock plus 7 is a 1, and 8 should be a 1. And those are all okay. And I think the rest of those, the default settings are fine. So let's put this back, dock the group, close it. Just click on that thing. Now we have to go to set the pins for this, how this dev board is set up. And so what next we have to do is go to MHC here. If this isn't in your top level menu, you have to go back and launch the Content Manager. There's a step you missed. But if it's here, then MHC is installed properly. And under this, Tools, Pin Configuration. So we're going to use the Pin Configuration tool to configure the pins. And notice it brings up three tabs in your next to your project graph. In this next section, we will use the pin configuration tool to connect the LEDs and switches to the MZ device according to the table shown on the screen. A number of things. First, I want to change all these analogs to digital. Don't ask me why, but at one point when I was doing these things, they wouldn't work right. And it was the initialization And I think somebody in the forum suggested converting all these analog settings, the default settings, to digital, and that seemed to help, so I just do it. If that's something's wrong with that, somebody can tell me, but like I say, this initial step in the project creation is we just want to get something to work. I mean, look at all the settings, and all it takes is one or two to be wrong, and you'll drive yourself crazy. So now we're going to go after those these switches and the LEDs that are on this board. So the first one is SW1, which is RJ4. So you can sort them by pin numbers or pin IDs, or ports. I like the ports. So we've got it down here to RJ4. And that's supposed to be switch 1, so it's available. So we change that to GPIO. It's in, and it needs a pull-up. And double click on this and change the name to SW1 switch 1. RJ4. Oh, there it is. Okay, RJ5 is switch 2. Okay, now let's pretend that I did this really, really fast, and the results are what you see on the screen now for all the pin configuration. We've got the multicolored LED, 3 pins, red, green, blue. We got all the switches defined. There they are, 3 of them, and the LEDs, 1, 2, 3, and 4. So we're ready to go. Okay, now what we have to do is fix some of the project properties. And there's a number of ways to do that. Go up to this top level menu and click on Project Properties for this project. A simpler way is to right click on the name of the project, go to the bottom here to Properties, which is the way I prefer to do it. Okay, so in this case, all families, I know that this is important, but let's pick it anyway. 32-bit MCUs, PIC32. Get the right device here. Remember, it's MZ, PIC32MZ 20480 FM, 144. Connected hardware tool. Because the board's plugged in, it recognizes it, and so that's there. And we have to get a compiler option, and that gives us an error, apparently an error message. But at this point, I don't think it's an error. I think this is a bug in something in their system. That is the correct name, and that is the correct device. So just go ahead and apply it. Notice the latest packet there, and we'll say OK. And these changes are reflected in the dashboard. There's the correct device family pack. There's the correct device. There's the correct tool chain, the compiler. And there's the debug tool Curiosity Starter Kit for this device. So we're set to go there. So now we have to configure the hardware component, the Harmony components. So to do that, we're going to go here and add the core component to the project. Remember, we downloaded it in first version or first video, but it never is loaded in the project yet. So double click this or drag it. I like to double click it. It tries to auto activate FreeRTOS. Let's say no for now. We'll add FreeRTOS when we need it. Okay. Now notice it adds another component to the project graph, which is good. And we'll select that and click the configuration option. So we'll want it to generate the application files, yes. And we'll have one application for now. And it's going to be called app. Okay, that's fine. Let's see. Not sure what these are, but these are new. But let's click them anyway. System ports, EMA, enable system reset, I don't know, OSAL. So what is it? The only one we haven't clicked is enable system DMA. Set to go. And so we now have to generate the source code, let Harmony generate source code based on all these settings. And there's, again, two ways to do this. MHC, generate code there. Okay, so you got to find that. The easier way is to look over here to this little icon, the iCode icon. Click on that. And we just say generate. And so it's generating all sorts of stuff based on our configuration. Great. So now, to see what's happened, now look in header files and source files, there's stuff there. It's created these the main C, the app C, the app H, config files, and so there's quite a bit of source code now in our project. One particular one that you might want to look at is down here on the source files, the config. Notice PIC32MZ, this is that name that we added, so that's the Harmony adds that under config. And way down here hidden under peripheral GPIO is this thing called plib gpio.c. So double click on that. And there's a bunch of the choices we made in the system configuration, and then also up here under the app H header files, we'll do the same thing. Go down here to peripherals, GPIO, and do the H one, header file. And here are all these macros. Remember when we named all the different switches and the LEDs? Well, Harmony then creates macros so we can use these names in our source code to turn LED on or off, toggle it, whatever. And it just creates a macro, and here's what it does to the various register settings. So that's kind of interesting if you want to know what's going on under the hood there. That's an interesting file. Also, down under the source file, initialization.c is also one that you should be familiar with, because this is where, remember those configuration settings, config 0, 1, 2, 3, and 4. This is where they get established in the source code. Creates system objects, calls the system initialize, and then sets some bits, initializes clocks. I mean, you're going to have to walk through this to understand it, but anyway, this is where it all starts. So that's pretty much a quick lesson in what Harmony does for you right off the bat. Now, we haven't added any custom code yet, but you've got a complete project. So continuing on, you say, okay, we've got all this source code, we know where it is, so let's see if it'll compile. So you go, okay, we're going to take a quick break here and explain what we're going to do next. In this next section, we'll compile the project, set up the debugger, load the program in the device, and execute some simple debug commands to show how the debugger can be used to troubleshoot your code. So let's go to MPLab. Okay, we've got everything loaded, configured, whatever. So we go up here to production, and we're going to check to see if all this work produces any code that will compile and load. So there's build the project, and down here, boom, there is the build successful. So that means our code could be actually running, but it may have bugs, so you have to run it under the debugger to verify that it works as expected. So first you have to make sure in the debugger, up here under preferences, this is on a Mac, I think the same menu will appear on a PC under the About menu. Anyway, it's down here, debug startup, following debug action, halt at main. Make sure that that's set at halt at main, and you'll see it gives you control over the debugger when it starts. So that was okay. So now we already know that the program compiles. So let's go up to debug the project. It will recompile it for the debug option and download it to the device. So yes, build is successful. And now it's going to launch the debugger, which is the onboard debugger in the dev board. This is very helpful for development, but on your own custom boards, you probably use a PIC32MZ or whatever, and it'll work just the same. So there's these different tabs here. Let's look at the output for the debugger. This is what, so okay, program verify complete, which is shows that it's been downloaded to the device and it's ready to be debugged. And because we said halt at main, there it is at the first step. So it gives you control of where you want to go. You can set breakpoints or you can step. We'll just do a couple of simple things. How about debug, step over, system initialize, let's step into it. And this is the same thing that we saw when we were the source code that we were looking at earlier. So we could set a breakpoint by clicking on a line number right here. And then debug continue, and it will go to that line number and stop. That's about all you need to really get started with the debugger. Debugger 101. Just step in, step over, continue, whatever, breakpoints. So then we'll finish the debugger, get back out. And okay, and we'll clear the breakpoint. There. And we're essentially done here for this video, this lesson. And so let's close the project. Okay, and exit. Exit the IDE. Now, why not? Okay. So now that we've finished with that, we've just created a Harmony project from scratch, configured all the software and hardware, and verified that the project compiles, loads without errors. And you should have learned the rudimentary steps to download and debug the project. I'm really sorry about how long this video turned out, but this is an indication of how much effort is needed to get a simple Hello World to work. Although this could be your base project on which you can build your own custom code, in the next video we'll look at some custom code to implement features that I find necessary in every project in the book to make a robust base project. So thank you for watching, and I'll see you in video number 3.